Hi guys, this is Mr. Urrego, and today we're proving identities. We have to prove that this left side is the same as the right side. When we're doing identities, we take one side at a time, right? We cannot do anything on both sides at the same time. I'll show you in a minute. All right, so let's prove this one. Before we start, there are many tips how to solve this. One is, if you see one side has fractions, then that's the side that you work on. If you have functions that are to the second power and you have pluses or minuses in between, then you got to use Pythagorean identities. That's another way how to start. If you tangent, cotangent, secant, or cosecant, and those are not squared, then what you have to do is turn them into sine and cosines and then add or subtract. As soon as you turn these functions into sine and cosines, they're going to become fractions. Okay, that's another idea. If you can apply any of the above, what do? Try factoring. Greatest common factor, difference of squares of trinomials, or even other math. Now, when you're doing identities, anything goes as long as the math makes sense and it's a logical process. Okay? Like I said here, if none of the above work, then and you have no idea how to start, turn everything in terms of sine and cosines and go from there. One more thing, we have plenty of identities. Reciprocal identities, Pythagorean, so every time you have something to the second power and pluses or minuses, that means you got to use this somehow. Cofunction identities, even and odd, every time you have an angle, here the data is negative. You see an angle that is negative, that means you have to use one of these. The sine and the tangent are odd and the cosine is even. All right, and basic identities, what's tangent, what's cotangent, and all the reciprocal identities. So this is the idea. Now, one more thing before we start. If you notice here, my angle is 2 theta. In order for me to use any of these identities, the angle does not matter. I can put here 2 theta and 2 theta, and still this will be equals to 1. I can do 2 theta here and 2 theta here, and any identity will work. Okay, so the angle does not matter and it doesn't change my identity. I can have theta, x, y, anything as my angle, right? One more thing, if you notice, my function is the one that has the square, not the angle. There's a normal mistake that people, instead of putting it here, they put it here, and that's wrong, not in my angle, okay? In the function, the tangent, the cosine, or the sine. Let's start. So I have this identity, okay. They're not to the second power, so I don't have to use that. Okay, I have 3 things on the left side and I have 1 thing to the right side. The way I approach this is, normally this is more complicated. So I'll try to use the more complicated and get into the other side that is more simple, more easy. I start thinking, what should I do? Okay, they're not to the second power, so I'm not doing Pythagorean identities. So I have no idea what to do. So let's turn this into sines and cosines. So tangent is the same as sine over cosine, plus cotangent is cosine over sine. I'm keeping the same angle, as you notice, right? And all that divided by cosecant, and cosecant is 1 over sine of theta. Now what? I have no idea. Okay, so, but I see that I have 2 fractions on the top, so let's work with those 2 fractions. They have different denominators, that means I need to have the same denominator, so I'm going to multiply this times this denominator, so times sine of 2 theta on the bottom and the top. The other side, I multiply by this denominator, times cosine of 2 theta, cosine of 2 theta, and I'll have the same denominator. So this is going to give me sine times sine is going to give me sine squared of 2 theta divided by sine times cosine, 2 theta, plus, I'm doing the top, cosine times cosine gives me cosine squared of 2 theta, and the bottom, sine times cosine, sine 2 theta times cosine of 2 theta. If you notice, okay, I'm working my way down. I don't go to the right. You always do identities on your way down, step by step. Okay, going down. And I have this 1 over sine of, oh, that should be 2 theta. This should be 2 theta, right? That's my angle. 2 theta. Okay. So what else? Now on the top I have the same denominator. That means I can combine those two. And I'll have sine squared plus cosine squared. Okay, no space on the bottom, so make me go up. So this plus this, because they have the same denominator, I keep the same denominator, which is sine 2 theta times cosine of 2 theta, right? And the top gives me sine 2 theta plus cosine of 2 theta. As we know, sine squared plus cosine squared is going to turn into, well, hold on, let's write the denominator. Bigger, 1 over sine of 2 theta, and let's erase the bottom. This is going to turn into 1. So I'll have 1 over my denominator, and this is the top. 2 theta cosine of 2 theta divided by this 1 over sine of 2 theta. Now I have a fraction divided by a fraction. How do I divide this? You can keep, change, flip, or however you divide fractions. The way I do it is I multiply the first times the last, and my answer is going to be on the top. That's going to give me sine of 2 theta, right? 1 times this, and the middle values, which is sine 2 theta cosine 2 theta times 1, will be in the denominator. And I hope you're seeing what's happening right now. Now what's happening? The sine 2 theta cancels, and if I cancel something, then I'll have 1 at the top. And now I have 1 over cosine of 2 theta, which is going to give me secant of 2 theta. And I finally got to the right side, which was secant of 2 theta. So that's the idea of an identity. Prove the left side equal to the right side. Let's work on a couple more. So let's work on this one. Same idea. What to do? How do I start? The left side has to be equal to the right side. If you notice, I have a square on the outside, but my functions are not square, so I cannot use the Pythagorean identities. I have no idea. So let's turn this into sines and cosines. So secant is 1 over cosine of x minus tangent is sine of x over cosine of x. Remember, all of that is to the second power. Okay, they have the same denominator. That's something. So let me add them. Because they have the same denominator, I keep my denominator and I add or subtract the top. And it's going to give me 1 minus sine of x. Remember, everything to the second power. Okay, I have that. That's fine. Now what? I can square the top and the bottom, so I can, square this. So my top is going to be 1 minus sine of x to the second power, and the bottom is going to give me cosine squared of x. And now I'm here. How can I get to this? I have no idea. So when this happens, what I can do is I already have something. So let me stop here, and now let me go to the right side, and hopefully I get to the same thing. But again, I have this. How can I turn this into this? I have no idea. I can do, I can turn this into using the Pythagorean identity. So I tried a few things and nothing didn't work. Okay, I ended up with nothing. I changed this into 1 minus sine squared, but I couldn't do anything because if I'm going to do something with the top, I will have to FOIL this. Remember, this top is the same as having 1 minus sine of x times 1 minus sine of x. So I tried that before and I FOILed this out, but it gave me something huge. It didn't work that way. I kept thinking, can I factor in? No, nothing. So again, it's not simple sometimes. So what I notice is these two have different sign. The top has a negative and the bottom has a positive. Okay, normally that's called a conjugate. So one is the conjugate of the other one. It says, whoa, maybe I can use that. So I decided to multiply by the conjugate. What's the conjugate of this? It's the same thing, but with opposite sign. Okay, minus sine of x. And if I do it on the bottom, I have to do it on the top. Okay, but if you notice, look at this. I'm going to have 1 minus sine of x, 1 minus sine of x. That times that gives me this. So this becomes 1 minus sine of x to the second power. And I already have the top. It's okay, nice. Now let's go for the bottom. I got to do FOIL on that. So 1 times 1 gives me 1. 1 times negative sine is negative sine of x. Sine times 1 gives me sine of x, and sine times sine gives me sine square of x. Okay, the top is what I want, so I'm not going to change it. 1 minus sine of x to the second power. Let's skip on the bottom. Negative sine of x plus sine of x cancels out, and I have 1 minus sine square of x. But what is this? So let me work on the right side. This is the Pythagorean identity. Okay? And if I need 1 minus sine, then what I'm going to do is I'm going to subtract sine from here and bring it to the other side. So cancels, and I have cosine of x equals 1 minus sine of x. And this is, I turned my Pythagorean identity into this, which means 1 minus sine square of x is the same as cosine. So this turned into cosine square of x. I rewrite the top, and voila. Left side equal to the right side. So that's another way how to prove identities. You try, you get somewhere, you leave it there, and you go to the other side and you try whatever you can. Again, all this is logic. This is regular math. Alright, so I'm not making up anything. You can use anything, factoring, Griscon factor, trinomials, anything. Okay, the idea is to get to the same on both sides. Alright, this is the last one. Now I have this. Okay, here we go. What to do? So I already have cosines and sines. So, it's not that I want to break this into sines and cosines. It's already sines and cosines. I have no tangent, nothing. But I notice that I have an exponent. Exponent. Alright. The right side is to the fourth power, but the left side is to the second power. So I need to do somehow something here in order for me to bring that exponent to the second power. Okay, because I have exponents and I have minuses, that means I can use my Pythagorean identities. Okay, but again, it's to the fourth power. Okay, what else can I do? I need to break this into several parts so my exponents break. How can I break things? Factoring. Okay, let me give you an example. If I have x squared minus 9, can I factor this? Yes. X plus minus, right? Square root of x squared is x, and x. Square root of 9 is 3 and 3. That's how I factor this. This is it's called the difference of two squares. Difference, square, because those exponents are even. So I'm applying a difference of squares here. How do I factor this out? Square root of this is going to give me cosine to the second power of t. Cosine to the second power of t. I'm breaking this into 2, right? 2. And then plus and minus, and I do the same thing with the sine. Sine square of t and sine square of t. And this is the left side. And if you notice, my exponents went down, which is what I'm looking for. Okay. Now what? Oh, hold on. Cosine square plus sine square, or sine square plus cosine square, this is equal to 1. All right, I got rid of all this because that's an identity. And I bring this one. And this one is cosine square of t minus sine square of t. All right, and now it's better because 1 times that is the same thing. Okay, now I'm going to have this because the 1 goes away, right? Excellent. What about now? Cosine square minus sine square. I have sine square, but I don't have cosine square. So that means I have to get rid of this cosine. We can use the previous identity. Remember the previous identity? Cosine square equals 1 minus sine square. So let's use that. Cosine is the same as 1 minus sine square of t. And I'm just replace this. And I bring down minus sine square of t. And now I have sines, which is what I wanted. Okay, but hold on. This and this is the same, right? And I have negative sine square minus sine square. That's negative 2 sine square of t. And I bring down my 1. And guess what? It's the same as my other side, which is what I'm looking for. Okay? So as you notice, we have done several different things in order for me to prove those identities. The idea is to prove them at the end that both sides are the same. We're going to do a few more, but in the next video. Okay? Please like the video, subscribe to the channel if you haven't done so, and I'll see you in the next one. More examples of this, so stay tuned.